Compare layer 2 and layer 3 devices. In this activity, you will use various commas to examine three different switching topologies and compare the similarities and differences between the 2960 and 3650 switches. Okay. Compare layer 2 and layer 3 switches. Examine physical aspects of D1 and ASW-1. Okay. This is logical topology, and this is physical topology. Okay. Logical D1 and ASW-1. Okay, you can go, for example, go to D1 and physical tab, and you can see the physical, and you can see the hardware of the device. Or you can go to physical, go to the CD, go to office, click, and office, go to main wiring closet, and also you can see this is D1, this device. Okay, D1 and ASW-1. This is D1 and this is ASW-1. Okay, go to logical D1. Each individual switch has how many physical ports? Okay, this is a 3650 switch and has 24 fixed ports, and 4 modular ports that accept SFP modules. 1, 2, 3, 4. 4 modular ports that accept SFP modules. Okay, ASW-1, physical. This is a 2960 switch. Okay, 2960 switch. 24 fast Ethernet ports and 2 gigabit ports. How many fast Ethernet and gigabit Ethernet switch ports does each switch have? Okay, D1. 24 gigabit fixed ports and 4 modular gigabit ports. 2960. 24 fast Ethernet ports and 2 gigabit Ethernet ports. List the transmission speed of the fast Ethernet and gigabit Ethernet switch ports on each switch. Fast Ethernet switch ports supports speeds of 100 megabits per second, and gigabit Ethernet switch ports support speeds of 1000 megabits per second or 1 gigabit per second. Are either of the two switches modular in design? Yes, the 3650. The switch ports of a 3650 switch can be configured as layer 3 interfaces by entering the no-switchport command in interface configuration mode. This allows technicians to assign an IP address and subnet mask to the switch port in the same way that they are configured on a router interface. What is the difference between a layer 2 switch and a layer 3 switch? A layer 2 switch makes forwarding decisions based on layer 2 addresses, MAC addresses. Switch ports on layer 3 switches can be configured as interfaces with IP addresses. The switches can also be configured with routing protocols like a router. What is the difference between a switch's physical interface and the VLAN interface? A switch's physical interface is used to physically connect end devices to the network. A switched virtual interface, SVI, or VLAN, is used to configure the switch with an IP address so that it can be managed remotely. At which layers do 2960 and 3650 switches operate? The 2960 operates at layer 2 and 3650 operates at layer 2 and layer 3. Show run command to examine the configurations of the D1 and ASW1 switches. Okay, go to D1 command line, enter enable show running config, space, ASW1 command line interface, enter enable show running config, space. Do you notice any differences between them? Okay, D1 gigabit interfaces. All ports are gigabit interfaces. And ASW1 fast Ethernet interfaces and 2 gigabit interfaces. Okay, D1's ports are all gigabit Ethernet, while 2960 has fast Ethernet interfaces and gigabit interfaces. Okay, go back D1, and you can see the number of ports are 101, 102, 103, 104, and on 2960 switches 01, 02, 03, 04. Okay, so the D1 has different designations for its ports. The D1 uses the stack module port format. Okay, and also on D1, 3650 switch D1, it has interfaces with IP addresses and subnet masks. Okay, D1 has switch ports that are configured with the no switch port and show an IP address and subnet mask. And finally, D1, the 3560 switch, D1 has IP routing enabled, and 2960 switch, no IP routing. Try to display the routing table on D1 and ASW1 using the show IP route command. Okay, D1, enter, show IP route. 2 directly connected networks, ASW1, enter, show IP route. Okay, invalid input. Why do you think the command does not work on ASW1 but works on D1? It works on D1 because it functions on layer 2 and layer 3, which allows it to function as layer 2 switch but at the same time allows it to route packets and make forwarding decisions based on layer 3 information, IP addresses, that conventional switches cannot. ASW1 is a layer 2 switch and therefore does not have a routing table. Compare layer 3 switch and a router. Okay, look at this is a router. In the past, switches and routers have been separate and distinct devices. The term switch was set aside for hardware devices that function at layer 2. Routers, on the other hand, are devices that make forwarding decisions based on layer 3 information. They use routing protocols to share routing information and communicate with other routers. Layer 3 switches, such as 3650, can be configured to forward layer 3 packets. Entering the IP routing command in global configuration mode allows layer 3 switches to be configured with routing protocols, which gives them some of the capabilities of a router. Although similar in some ways, layer 3 switches are different from routers in many other aspects. Open physical tab on D1 and R1. Okay, D1, physical tab, R1, physical tab. Do you notice any similarities between the two? Do you notice any differences between the two? Okay, this is the router R1. This is modular. Okay, modular, and you have these spaces to add more cards or interfaces. Okay, USB ports. Okay, console port using USB, gigabit Ethernet interfaces. Okay, go to D1. Okay, USB port, console port, gigabit Ethernet interfaces, 4 modules. Okay, they both have a console port, USB ports, and gigabit Ethernet interfaces. Both R1 and D1 are modular, meaning different interfaces can be added. R1 has serial and asynchronous interfaces, while D1 only has Ethernet interfaces. D1 can use copper or fiber-based Ethernet, depending on the modules that are present, and R1 can use various connection types, also depending on the modules in use. D1 has many more gigabit Ethernet ports than R1. Issue show running command and examine the configurations of R1 and D1. Okay, D1 command line interface. Okay, show running config space R1 command line interface. Enter. Enable show running config. Enter space. Okay, go to D1. And you can see, for example, gigabit 111, IP address 192.168.10.1, subnet mask 24, gigabit 112, IP address 192.168.11.1, subnet mask 24. Go to R1, gigabit 000, IP address 192.168.10.1, subnet mask 24, and gigabit 001, IP address 192.168.11.1, subnet mask 24. What differences do you see between the two? R1 and D1 have the same IP addresses configured on them, but on different interfaces. Which command allows configurations of D1 with an IP address on one of its physical interfaces? Okay, go to D1, the no switch port command. Show IP route command on both devices. Okay, D1, enter, show IP routes, two directly connected networks, and R1, enter, show IP routes, two directly connected networks, and also you can see the local interfaces. And do you see any similarities or differences between the two tables? Okay. The codes are the same, except the router has an L code for local. This is a link that is configured on the physical interface of R1. The switch routing table does not have this code. Both devices display the same networks in their routing tables. Okay, 192.168.10.0, 192.168.11.0. 192.168.10.0, 192.168.11.0. Now analyze the routing table of R2 and D2. What is present now that was not present in the configuration of R1 and D1? Okay, go to D2. Enter, enable, show IP route. Okay, you can see this. Go to R2. Enter, enable, show IP route. Okay, now you can see OSPF routes on R2 and on D2 OSPF route. What is present now that was not present in the configuration of R1 and D1? They both have OSPF configured and both are learning networks from one another. Okay, because they are connected. Both are learning networks from one another. Which network is in the routing table of D2 that was learned from R2? Okay, go to D2. And now you can see this OSPF network. And is this. Okay, this remote OSPF network. 111.0.24. Okay, D2 has three directly connected networks, 1, 2, and 3, but this is the remote network. OSPF is this. And was learned from R2. Verify that each topology has full connectivity by completing the following tests. Ping from PC1 to PC2. Okay, from PC1. Common prompt, ping PC2. 1110. 192.168.11.10. Success. Ping from PC3 to PC4. Go to PC3, desktop, common prompt, ping. PC4 IP address is 1110. 192.168.11.10. Success. Ping from PC5 to PC6 and PC7. Okay, PC5, desktop, command prompt, ping PC6, 1010. 192.168.10.10. Success. PC7, 1110. 1110. Success. In all three examples, each PC is on a different network. Which device is used to provide communication between the networks? Okay. Multi-layer switch, router, and multi-layer switch. Why were we able to ping across networks without there being a router? A multi-layer switch can route between networks as long as it is configured with an IP address and has IP routing enabled. IP routing must also be enabled if you plan to run routing protocols such as OSPF on the switch. The no switch port command must be enabled on the interface in order to assign an IP address and subnet mask on the switch's physical interface. We say that routers are layer 3 devices and conventional non-layer 3 switches are layer 2 devices. However, we can assign an IP address to manage SBI interface of a layer 2 switch. How is this possible if switches are layer 2 devices? Managed layer 2 switches, such as the Cisco Catalyst 2960, have an embedded server that can be reached over layer 3. The server enables Telnet SSH or HTTP access to the switch from across the network, so that the switch can be remotely managed and configured. It is useful to think of this functionality separate from the data forwarding function of the switch, which exists at layer 2. Thank you very much.